Hello, everybody. Welcome. I'm Andrew Miller. I'm here to talk about the most exciting topic, which of course would be archive, right? Because, I mean, this was me when I was a backup admin, right? I loved archives and they made me excited, and actually probably not. I don't think that's anyone here. That's actually why we're starting this, because this is a pretty foundational, interesting thing. Very briefly about me, I'm going to allude to this as we go along. I have tech marketing responsibilities here at Rubrik. More importantly for today, was on the customer side for 7 years, admin, architect, engineer, 8 years on the partner side. And the kangaroo picture is not actually for Justin, it's actually my standard intro picture, truly. You can look at other presentations and I have it there, just because it makes me happy. So, as Chris mentioned, we're going to be going through looking at 4 different sections. The first is going to be around CloudOut, which is our archive capability. What we realized as we were going through preparing this is we've had this capability for a really long time, but in this audience, we've never actually done a deep dive on why so many of our customers are using it and what the actual underlying technology is that makes it different. Because there's other archive solutions out there, but there's actually some cool deep down technical stuff here. This is in the context of what we're seeing in our customer base. And we are literally seeing 70-80% of our customers using CloudOut. That's what we call it. That's the marketing name for long-term archive in the cloud. And this is around long-term retention in the cloud. And the goal here is usually eliminating tape. No one really loves tape, but you need it, right? It's accomplished goals that are worthwhile. But if there's a way to avoid it, people get very excited about that, as shown by the adoption numbers. So how does it work? In this case, we go and we're protecting your data, your applications, your data on premises. And then at that point, it's going and archiving it out to the cloud. It can stay local. And this can actually be data that's protected on your main site, or actually can be protected on the cloud and then actually archived to the same cloud, to another cloud provider, et cetera. It's relatively agnostic that way. So the primary use cases we see, as I referred to, is tape replacement, just because no one really likes this. But this is almost kind of table stakes, right? You need to be able to do this because then, just like we talked about, no one really loves archives. So the goal is that we start to unlock the data to be able to do more with it. At the point where you've got the data already in the cloud, then you can actually go and start to do things with actually lift and shift. Actually, you've got the data and you can convert it. That always usually gets a little bit of a like, hey, that's fun. Or then you can go and use it for test dev. You're converting the archived VMs that are running out there on a temporary basis for test dev purposes. Or even, disaster recovery is the flip side of that. You convert the VMs to run in the cloud, and then you leave them running there, right? Or that's a lift and shift, or it's a disaster recovery. So with that, we're actually going to go into a demo. This is meant to be pretty short and sweet from a foundational setup perspective. What you're going to see in the demo is first around the breadth of options, that no matter what cloud provider you're using, it's a similar experience with multiple storage classes and some stuff about compliance in there. And then as well, we're going to actually walk through how this works from a file restore, VM restore, or even instantiation. And then after that, you'll be like, that looks pretty cool. And we'll do a little bit of a deep dive about how this is actually working. You'll see the experience and then how it's actually working. So with that, I will pull the chair over. And while I'm going here, any questions so far? I may hit them later in the deep dive, but as I go jump over here.
When you say archive, you mean long-term backup retention?
Yes, but it can sometimes be even short-term. Sometimes people just want to keep 30 days on site, and maybe it's only 90-day total retention. So to me, sometimes that's not necessarily long-term. That's regular kind of normal stuff.
But it's a backup retention thing. It's not a data archive.
Correct.
Archive is different.
Well, in this case, yeah. Well, I'm happy to agree with the kind of term definition.
Possibly. So I'm interested in. It will be interesting to see how this links into things like with Polaris later, perhaps, about when you say that the data is there and you're able to do things with it. Mm-hmm. That is the important part of archive.
Yes.
Is that I need to be able to do stuff with that data well after I'm no longer able to spin up a HP UX9 system.
Mm-hmm. Agree.
Okay.
So we're going to walk through a little bit of setup, see the simplicity, and we'll walk through a little bit of the restore experience. So when you go to set it up, and this is a live lab environment, as you can see, with some SEs potentially around the world demoing stuff. So you go up to archival locations. Hopefully this is large enough for everyone to see, roughly. I can make it a little bigger. So when you go to add an archive location, as we mentioned, there's support for Amazon, Azure, Glacier, Google Cloud Platform. You can even do stuff if you need to around tape and object stores, as Cloudian, Clever Safe, et cetera, on premises. But we're focused on the cloud aspect here, even NFS. And when you do that, then of course you have things where you're going to choose your region. You may have different types. So like, for instance, let's even just say, Google Cloud Platform. Popular option there is cold line. There's some good cost economics there relatively in response time. And then of course there's pieces around encryption that you need that are, and this is specific to the cloud provider based on their capabilities, but everything is encrypted before it leaves the Rubrik cluster and sent up to the cloud. At that point, once you have that created, you can actually go and relatively easily, and I'm saying this from having been a backup administrator before, not calling products out by name, but I used to stare at this stuff and look at the failed jobs and tasks and schedules, and it's like, you come in every morning and get a little bit sad when you have to do it. But in this case, as Chris mentioned, one of the core pieces of Rubrik is our policy architecture, and that is around that you can set up. You don't have to set up jobs and tasks. You tell the system what you want it to do, and then it complies with that. So in this case, I'm going to make a quick policy of, say, let's take a backup every, say, 12 hours. Keep those ones for 3 days. Every day, keep it for, say, 30 days. Every month, keep those for a year. And this is just the setup to get to the archive piece. But this would be a kind of common piece. 7 years, of course, is a common long-term retention for various regulations. But when you go to configure remote settings, it's literally a radio button. And then you drag a slider of how much data do I want to keep locally. This is dictated by most of your restore requests. For most customers, come in within 30 days, 60 days, 90 days. You know kind of how long that is. And then that's the data that you want local for fast restore. But if it's stored somewhere else, you don't want to have to think about it and track it and move stuff around. So that actually leads into what is the restore experience like. We'll cancel out of this guy. And Ken was kind enough to let me use his virtual machine, which I appreciate. It made the demo switching a little bit easier. So you could navigate to virtual machines through the sidebar. In the interest of time, we're just going to search to pull it up.
Yeah. So while that's coming up, can you explain how you're defining what an archive is?
So in this case, an archive would be a target for long-term data retention, whether that is a cloud provider, usually blob storage of some type, or S3, of course, object storage, or it's an on-premises environment, whether that's NFS or table.
So it's just keeping a backup for whatever period of time that you've set.
You're specifying. Correct.
Okay.
Correct. Our terminology. So this is the common view for any object within Rubrik. And anytime that you see a little green dot, it means there was a successful backup or data ingest at that point. So we're actually going to go back here, and we'll actually go back to, let's go back to the 6th. Actually, we'll go back here a little further. Go back to January. Because this is, it's aging out the backups over time, not taking new ones, but it's pruning them out, like that policy we showed earlier. So we click on this guy, we'll actually see, this snapshot is in the archival repository. So you're aware of it if it's there, if you care. And if you want to actually go to pull it back so it's now local on the brick and you could fire that virtual machine up because there's a virtual machine being backed up, all you have to do is say download. It'll then pull back just the changes needed. We'll go back into that in the deep dive. We'll go into that in the deep dive in a second. But that's one scenario. What if you just want a single file? Of course, host file, because everything has a host file, right? It's the most common search demo ever. But in this case, because we still keep all the metadata locally and stored in Flash, if we look at this, we can simply choose any of the ones that we want. And as you scroll down here, even in the single file view, you'll see there's a little icon to show you, it's out there. It's only stored in the cloud. But when you pull it back, if you choose this one, it'll just pull back the blocks needed. Again, we'll go further into that in the deep dive. This actually really came home for me. I have a friend who works at a law firm in Charlotte, and they had a pretty common scenario where they have a document management system, and all the file names are in hexadecimal. Kind of crazy, right? So when they would have to go to do restores, it was very painful because there'd be hundreds of thousands of files in the various directories. So just navigating to the date, expanding the folder tree, you wait for that to refresh. Oh, it's not in that one. Then you go to the next one, you go to the next one. So it was actually a scenario where anytime they'd get this, they'd kind of cringe these restore requests because it's the lawyers. They've got to comply or respond. It's their customers, and they're lawyers too, right? So it would take them a couple hours for each one of these sometimes. He was incredibly excited as he was talking to me about, it literally takes him this same kind of request. He types the first couple letters of the name because it doesn't have to get too far to be identifiable in hex. And within 5 to 10 minutes, he can bring it back, even if it's actually archived out in the cloud. So this is just like super real world impact. It's a guy that I've worked with for 10 years now in different capacities across a couple different companies. So kind of friends on a personal level. Just it makes me really happy to hear that story about how it just helped him on a day-to-day level.
So Andrew, the metadata becomes incredibly important
Yes.
to overall operations of not just this scenario, but everything Rubrik is sound.
Mm-hmm.
What happens when the metadata database is corrupted?
So in this case, we take metadata very seriously, or we can call it a catalog, we can call it metadata. So we actually have multiple ways that we protect metadata. We actually triple mirror it internally. We have constant checksumming and error correction. There's actually a white paper around this, a data integrity white paper. And as well, we even store the metadata up in the cloud archive as well. So if in some way the on-premises, your data center goes away somehow, that's still recoverable, which is critical, especially when we're talking long-term retention. So
there's versioning, and so
correct.
When, let's say that I have to go back to a copy of the metadata that's aged out, and there's 100,000 changes between when my backup copy and my restored. How is that index recreated for the delta between when it was destroyed and when I backed it up and when I recovered it?
Do you mind if I hit that in the deep dive section in a minute?
You can
Is that all right?
definitely do that.
I promise I will. I'm not trying to be that. I'm gonna, but
No.
that fits really well right there, if that's all right. Last piece, and actually we're like there in 60 seconds, so thank you. The next piece is here. If you look at this guy, you'll see this is one that's already been downloaded, a snapshots that's already been downloaded, and then of course you can go in and see if there's later ones. And actually, I think that's the demo. I should have just jumped over, Keith. So
No, that's okay.
yeah, I was like, yeah. Let's go back.
Can I just ask a quick question
Yeah.
on your snapshots? Are all of those snapshots incremental from the very first
Yes.
full?
After we take the first full, we only take incremental snapshots, and that's actually where you are.
So in terms of what you push to the cloud,
Yes.
do you push the full and the incrementals, even though you might only archive some of the snapshots? Because if you've only got the snapshots in the cloud and you lose your on-prem image, you can't use the snapshots potentially because there might only be differences between that original first copy and subsequent ones.
We're actually tracking to make sure that we always keep a full on the brick locally, as well as whatever changes are needed for the deltas to comply with the amount of days should be local.
Yep.
We always make sure to keep at least a single, if not more, fulls in the cloud.
Right.
And there's even some intelligent algorithms there based around snapshot chains and length and that kind of stuff.
Okay. So if you lost the on-prem appliance, you're not just pushing snapshot delta blocks into the cloud. You have got a full copy to retain the whole thing.
Correct.
Yeah, and
That's even.
like with the way that all of the backup stuff that happens now because of things like flash and disk, basically everything is this synthetic full now.
Correct.
Because it's not like the old tape thing where you have a full and then you just do incrementals. It's like, that's actually happening constantly and it's rebuilding a synthetic full the whole time.
Incremental forever, every restore looks like a full.
Yeah,
We're doing all that
the
under the
tape
covers.
side of that tape analogy of full and incrementals doesn't quite translate to the way modern backup systems work.
And we still sometimes use that terminology just to help be relatable, or just people are used to the term.
Yeah.
But the terms that I'll often use is it's an incremental forever after the initial full, and then every backup looks like a full, or it's a synthetic full. We're compiling that. There's no concept of reverse incremental, forward incremental, having to figure all that out and manage it. But we're giving you that same end result of every backup looks like a full.
The reason I was asking the question is just to understand the volume of data that you might be pushing to the cloud. So obviously you're pushing, at a minimum,
Yes.
an image of every single VM
The
plus
first time.
snapshot. So
The first time.
what sort of typically?
I'm even going to go.
Oh, okay.
I'm going to go here.
I'll let you carry on. Sorry.
Oh, good. I was like, I don't want to be that guy. So I was like, man, it's right there. So, first piece actually, and I'll jump right there, is as we take backups, we actually index the backup, whether this is just at a file level or just virtual machine backups, right? There's Windows and Linux and other stuff in there. If it's a virtual machine, we actually crack inside the VMDK and index inside that, right? So that's how we can have that single file restore. We're seeing all that file restore inside virtual machines. As we do that, because we actually know, we track this first full backup, right? And then we're tracking just the blocks that have changed. We're storing those both on the brick, and we're incrementally transmitting those up to the cloud in a incremental forever, deduplicated, and compressed method. This to me is huge because I have friends at both customer side and other manufacturers where they actually have cloud archive features that they don't use. And the reason they don't use them is because it's too expensive from an ingress-egress cost perspective kind of thing. It just doesn't work for them. Because we are actually only sending the incremental changes, that has a dramatic impact on the cloud bandwidth cost which is why we see that 70-80%. So many of our customers are actually truly using this feature. It's a foundational one that, as Chris referred to, has been in Rubrik with S3 since even almost day one. Similarly, the reverse of that is restore, right? And if there's the whole thing, if you can't get your data back fast enough, it doesn't really exist, right? Even from potentially an archive perspective. So here we are just sending back the changed blocks. And the interesting thing is here that we're always keeping a copy of, say, the virtual machine, unless you've just permanently archived it out. It's on the brick. So when you say, I want to go back 3 months ago, we can track just the blocks that you need that are different from what's stored on the brick to bring that back. And then we're even doing the same thing with files. So the easy way to explain this is that if you have a 100 gig VMDK and you need a 1 meg Word file because it's XML inside the docx, whatever, so that kind of thing, a couple characters, we will just pull back the bits that are needed, even if that was from a year ago, right, kind of thing. So, and when you're doing this, you don't have to think about, is it in Google, is it in S3? You could even have some pieces of, maybe you've changed that archive policy. You can still see that, and the data may be somewhere else, but you don't need to think about that from a day-to-day restore perspective.
What determines whether you keep the image on the brick locally? So after a while, if you're running out of space on that brick, do you get rid of that copy, or you always keep a copy locally?
There's always a base copy locally, and that copy may be rolled forward in time to comply with the policy, but there is always a base copy locally. Encryption. Oh yeah, please, Ned.
Two things. One, is it possible to throttle how much network bandwidth the brick is using to send data up, especially for that initial copy? I know that can be rather large.
Yep.
And I've seen situations where it'll eat up the whole internet pipe for a few hours, and that's bad.
Generally.
Yeah.
Yeah, that would fit the definition of bad for just about every customer, I think. Yeah. So yes, there are multiple ways that we handle that.
Okay.
One of our advisory SEs, Josh Stenhouse, has a great blog on one approach that there's some built-in pieces to the product as well. So yes.
Second thing, you mentioned that you're indexing the content of what's in the VM. Mm-hmm. Are you also diving into the files themselves and indexing that content? Because part of an archive is that discoverability, not just at the file name level, but at the contents of a file or an email or something like that.
So today, we are indexing the file names.
Ooh.
Today. It's a very careful answer, obviously. But
right.
I absolutely agree with the point, and there are many discussions to be had on that. So, yes.
Building off,
Yeah, Jeff.
off Ned's question, GDPR would probably, you would want to be able to discover any data related to a EU citizen. So are you factoring that in your roadmap, or?
Yes, and actually we have a lot of, at this point, a lot of content and webinars around GDPR. We're very careful about that. We help with GDPR compliance. We don't make you GDPR compliant, right? But we've actually mapped Rubrik features very carefully, the various aspects of GDPR, and have a good bit of content online, because that's been a big focus for us.
Okay.
Please.
As you're compatible with the 3 most important cloud provider, and the archive is for long-term storage, if I change of provider between this time, may I be able to rebuild an archive from maybe Amazon to an Azure provider?
So if you change the archive target, which actually we do see customers do, because maybe 2 years later you're getting better pricing from one provider versus the other, new data will start to go to that new archive target. The old data will still stay in the archive target in the previous archive, and the reason we've seen that most customers leave that is because the egress cost to pull all that data back out is not cost effective, but you can change and not have to worry about that it's in 2 different spots. So far we're not seeing people try and pull the data back out just because the cost is too prohibitive from a cloud standpoint, but you can start to send new archive data to a different spot in the same policy.
Okay, cool. Thanks.
Briefly about security, this is almost a little bit of a recap of what Chris mentioned, but so we've hit on it in this section. When we look at this, there's AES 256 as well as TLS 1.2 applied in the right ways in different spots. The summary of that is that the payload is encrypted when it's transmitted, whether that's inside your data center or being sent out to the cloud, whether that's via SSL or via the appropriate APIs with cloud providers. That's often TLS 1.2 for replication or via the cloud providers. Data is encrypted locally. Of course, this is going to be AES 256. And then this can be done at a data at rest standpoint with either keys that are built in from a TPM standpoint, so you don't have to manage it, it just works. Or if you do have a KMIP compliant server, you can have keys managed in your enterprise environment, which for a lot of enterprises is critical. Small to medium customers, you often don't have a KMUP server, but if you're an enterprise, it's a critical piece.
Can you just go back and talk about the multi-cloud piece again?
Please.
So, if you're using more than one cloud, or if you're using an on-prem object store or whatever, I can just mix and match. I can use any one at any time. I can just stop using one and start using one and just leave it all out there.
Correct.
Okay.
Sure. So I actually didn't pull this one screen up in the demo, but in the SE lab, it actually shows there's Azure setup, as well as AWS, as well as a local NFS mount, all simultaneously out of the same cluster with different policies sending archive data different places.
Right. So what happens if I'm using vendor X, which has been working for a while. I now flip to use vendor Y. Do you have to pre-populate it again with that initial image, that's that baseline image? Because otherwise, I might not be using that anymore.
For that new archive, yes.
Yes.
As a baseline,
but once you've done that, then you just can carry on.
Yep. Okay. So we can have the same functionality that we've described otherwise. Yeah, because we don't want that full to refer back across different archives.
Right. Okay. So you deliberately make sure that you're not spanning in order to do a recovery.
Correct.
So you're not dependent on one if one goes away.
Exactly.
Okay.
From a summary perspective, hopefully this is obvious recap, right? Simple native integration. You don't need specific cloud expertise to be able to leverage this. Cost effective. A lot of people want to be able to consume public cloud, and sometimes it's hard to figure out how to start. And not just for technical reasons, but for also cost reasons. And the reason that's actually possible is because there's some actually intelligent data, some intelligent architecture and technology under the covers to make that possible. With that, I think I am going to hand it over to Ken so we can keep on track.
Can I ask just one question?
Please.
Just to hopefully derail everything. You're not allowed to stay on track. That's just the rule. I've understood. Anyway, from a high-level perspective, if someone's just looking at a solution like this, someone who's not necessarily has a technical capability or willing to get into the weeds, if they look at tape, they get some comfort from that physical separation that if something happens in the backup environment, your metadata, despite all the controls, that's lost. They can still pull the tapes back. How do you give that comfort when you kind of take that physical separation away and you're now using that archival, which is online?
Yep. So ironically, I'm seriously tempted to go into my 30 to 40-minute presentation around ransomware and Rubrik. I won't do that. I'll be kind. But the key concept in there that relates to this is the idea of immutability. So once we take a backup, we mark it as read-only, and it can't be changed. And there's even multiple pieces that can go into that to get people to where even in ransomware scenarios, it can actually be potentially more sure than tape. So I realize that's a relatively brief answer, but the key piece there is immutability, because some systems can be configured to be immutable, some can't. Some are immutable by default, which is Rubrik, and that's because we control the file system, the application layer, et cetera.
So does that protect me from the rogue admin nuking all of my catalog data before they quit?
I will make you no promises about rogue admins in your data center, physically or otherwise.
Okay. But there was what they called code spaces went out of business because they had someone who came in and deleted all of their systems, which were cloud-based, and all their backups as well. So having some separation of control built into the way that you do things is important to protect against that kind of value scenario.
And actually, the one piece that I didn't show, because I was trying to keep the demo going relatively quickly, that's where for the customers that have a specific need there, because there's some that talk about only a few that really go all that way down. That's where you go into Glacier, and there's vault lock compliance, and that's even one of the pieces that is the best answer there. When it's like, man, I have a need and I have enough budget to reflect that need. That's often the direction we go, or to worm compliant type storage.
Okay.